Hello dear children, how are you all? I hope all are fine. Stay home, stay safe. In our last class we had a discussion on very important result. Whenever limit extends to a of x power n minus a power n whole divided by x minus a, that becomes n into a power n minus 1. And related problem na discuss pannidini. So in this class I am going to enter into the new concept, how to evaluate the limits whenever we have the trigonometric functions. So before going to problem, I would like to discuss about very important theorem, limit as extends to 0 of sin x divided by x and tan x divided by x and 1 minus cos x divided by x. Then discuss martin. So before going to that discussion, I would like to discuss about very important theorem. Take the heading, limits of trigonometric functions. So we have the theorem, this is very important one. Let f and g be two real functions. They are the two real valid functions with the same domain. It means both f and g have the same domain and they are real valid function such that f of x is less than or equal to g of x. The function f of x is always less than or equal to g of x in entire domain. So what they define there, that is for all x in the domain of definition. For some a, if both limit as extends to a of f of x and limit as extends to a of g of x exist, then so we have very important result, limit as extends to a of f of x is always less than or equal to limit as extends to a of g of x. This is very important result. So this will give the for next theorem what we have, sandwich theorem, that is very important one. So this is very important. So theorem ಏನು ಹೇಳುತ್ತೆ, let f and g are the two real valid function have the same domain such that the given condition whenever f of x less than or equal to g of x, for some a both limit as extends to a of f of x as well as limit as extends to a of g of x. It means limit exists for both f of x and g of x at the point x is equal to a. Then limit as extends to a of f of x is always less than or equal to limit as extends to a of g of x. Okay, so I will give a diagram for this one. Okay, just observe body. Here we have the function y is equal to f of x. Y is equal to f of x, and so here we have the point x is equal to a. Point x is equal to a, and we have another function g of x. This is a point here. This is the g of x. This function y is equal to g of x. Will not observe ಮಾಡಿ. The function f of x is less than or equal to g of x, right? So g of x and this f of x is below the g of x. It means f of x is always less than or equal to g of x, and so both the function f of x and g of x have the limit at x is equal to a, or limit exists for the function f of x and g of x at x is equal to a. Then so there already we have the condition f of x is less than or equal to g of x, hence limit as extends to a of f of x is less than or equal to limit as extends to a of g of x. ಅರ್ಥ ಆಯ್ತಾ ಮಕ್ಕಳ? ಸ್ಟೇಟ್ಮೆಂಟ್ ಬರ್ಕೊಂಡು ರಿಸಲ್ಟ್ ಬರ್ಕೊಂಡು ದೆನ್ ಗೋ ವಿತ್ ದ ಡಯಾಗ್ರಾಮ್. ಸೊ ದಿಸ್ ಈಸ್ ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ 0, y, this will be x, this is y axis. Take a pause and note down all the things what I have displayed here. Now dear students, we are moving to the very important theorem, sandwich theorem. Just remember the word sandwich. So we have something in between two layers, right? That is the case here. Let f, g and h be real valid function f, g and h are the real valid function such that f of x is less than or equal to g of x less than or equal to what? H of x. For all x in the common domain of the definition. For some real a is some real number, if limit as x tends to a of f of x is equal to L. What is the limit of the function f of x when x tends to a is L? At the same time, limit as x tends to a of h of x is also L. So both the function f of x as well as h of x have the limit L when x approaches to a. Then, so what is the result then? Limit as x tends to a of g of x. Limit as x tends to a of g of x is equal to what? L. It means whenever limit exists for f of x and g of x and their limits are same, then obviously the limit of the function g of x, what were the middle term? That is also L. Nodi again. Limit as x tends to a of f of x, that is also L. And limit as x tends to a of h of x, that is also L. So both the limit of the function f of x as well as h of x is L. At the same time, that limit is also applicable to the middle function, that is g of x. That's why limit as x tends to a of g of x is equal to what? L. Just we will observe a diagram for this explanation. So this is the y-axis, horizon, this is x-axis. So here we have some function. This is the point x is equal to a. So this is called as function y is equal to f of x. Y is equal to f of x. And we have another one. This is y is equal to g of x. Y is equal to g of x. And we have another function. This is y is equal to h of x. Just observe here. F of x is below the g of x and g of x is below the h of x. So obviously this satisfies the condition. What we have? F of x is less than or equal to g of x less than or equal to h of x. And all these functions, what we have here, h of x and f of x, they have the limit L whenever x approaches to a. Whenever x approaches to a, it means at the point x is equal to a, limit exists for both the function f of x as well as h of x. Hence, limit of the function g of x when x approaches to a is also becomes L. This is the statement of this theorem, sandwich theorem. Very important theorem. Write the statement, then go with the diagram. Take a pause and note down all the things what I have displayed here. Now dear students, we are moving to the very important theorem. Prove that limit as x tends to 0 of sin x divided by x is equal to 1. So we will prove this result using sandwich theorem. So just go through the sandwich theorem and the statement of sandwich theorem, then come to this topic. Prove that limit as x tends to 0 of sin x divided by x is equal to 1. So write the statement. So now we will discuss about the proof of this theorem. Just observe here. Here we have the unit circle. This is the unit circle. Unit circle means whose radius is 1 unit. So here we have the center. Take center as C. Center as C. Draw the line segment AB perpendicular to the radius. So this is, take the point as A. So now I will take the line segment AB. This is the point B perpendicular to OA and join AB. So So point of intersection of this line segment with the circle, that point as C. Next, draw the line segment which is perpendicular to OA and take the point as D. Then join AC. So this angle, what way we are? Angle OAC becomes X radians. X radians. This is the diagram. Discuss about the proof. Observe here. Consider an unit circle such that the angle AOC, this angle AOC is X radian. X radians. Angle is X radians. Draw the line segment CD and AB perpendicular to OA, perpendicular to OA, and join this one AC, join AC. Just observe here. If you observe carefully for this diagram, so here with the triangle OAC, one triangle form agide, and so we have the sector OAC, there is also sector, and we have the triangle OAB. Just observe carefully. The area bounded by the triangle OAC is less than what? Area bounded by the sector AOC, right? So this is the triangle. E area barutte namage, and triangle AOAC, and this area of triangle less than area of the sector OAC. Obviously this sector is always less than. So what was the triangle? OAB. So using this concept we will prove this result. What was the result? Limit as x tends to 0 of sin x divided by x is equal to 1. Okay. So what we conclude here? Then area of triangle, first triangle OAC less than area of sector. So what was the sector? That is also OAC, that is less than area of triangle OAB. This is very important. This concept is clear here. Okay. Area of triangle OAC less than area of sector OAC less than area of triangle OAB. So just remember the formula for to find the area of the sector. Just remember the formula. So area of the sector, we have the formula. I'll write here. Area of sector is equal to theta divided by 360 by irodu. In particular, theta divided by 360. Theta is the angle into pi r square or area of the circle. Theta divided by 360 into area of the circle. So but we are taken here radian. So 360 gives the interior angle of the circle. So when you convert 360 to radians, that will get 2 pi. We get 2 pi. Therefore area of triangle OAC. So area of triangle OAC is half into base into what? Height. Half into, if a triangle OAC, base is here OA and height is CD. This becomes OA into CD. So this is less than area of the sector OAC. That is also what we have here, x divided by 360 can be written in radian form as 2 pi into area of the circle pi r idalva, r is nothing but radius. Therefore r square enaguttappa OA square agutte. OA is nothing but here radius, OA square. Less than area of the triangle OAB, half into base is OA into height is AB. Height is AB. Artha aitha mukla? This is the concept. Here we have the triangle OAB and the corresponding area is half into OA into AB, half into base into height. Just observe carefully here. So here pi and pi get cancelled. So here we left it. I will rewrite this as OA divided by 2 ಬರಿಬೋದಲ್ವಾ, OA divided by 2, just multiply 1 by 2 for OA into CD less than x into OA whole square ಇದೆ. We have repeated 2 times, that can be written as OA divided by 2 into OA ಬರೆದಿದ್ದೀವಿ. So both are same here and this is less than OA divided by 2 into AB. Just observe in this inequality, OA divided by 2 is common, right? Then how to eliminate this term? So here OA by 2 is multiplied with all the terms, that's why we have to divide by, okay? Throughout divide by OA divided by 2. Throughout divided by OA divided by 2, we get. So what we have done here, left hand here first term we have OA divided by 2 into CD ಇದೆ, whole divided by OA divided by 2 less than second one x into OA divided by 2 whole divided by OA divided by 2 into OA we have less than OA divided by 2 into AB whole divided by OA divided by 2. And here OA divided by 2, OA divided by 2 get cancelled. Here OA divided by 2 and OA divided by 2 get cancelled. Here also OA divided by 2, OA divided by 2 get cancelled. So what we finally we left with here? Here first term is CD. CD is less than x into OA, that is less than AB. This is a concept here. ಅರ್ಥ ಆಯ್ತಾ ಮಕ್ಕಳ? CD is less than x into OA, that is less than AB. So call this inequality as 1. Call this inequality as 1. Now from triangle ODC, just observe the triangle, right angle triangle ODC. So we will take trigonometric ratio sin x. Trigonometric ratio sin x. And observe here. So what we have defined here, sin x is the angle. So this angle, radians idella, that angle is in between 0 to pi by 2. This angle is in between 0 less than x less than pi by 2. It means theta lies in which, or angle lies in which quadrant? First quadrant. 0 less than x less than pi by 2. Therefore sin x becomes, sin x is equal to opposite divided by hypotenuse. What is opposite here? Opposite ಏನಾಗುತ್ತೆ ನೋಡಿ ಇಲ್ಲಿ, CD divided by hypotenuse is OC. CD divided by OC. Therefore CD ಏನಾಗುತ್ತಪ್ಪ, take cross multiplication, OC into sin x ಆಗುತ್ತಲ್ವಾ, OC into sin x. Just observe here, OA and OC is nothing but they are the radius of the circle. Hence in place of OC we can replace by OA, because we have to get the expression for OA here. ಓಕೆ. ಸೊ ದೇರ್ ಫಾರ್ ಅದೇನಾಗುತ್ತಪ್ಪ ನಿಮಗೆ ಸಿ ಡಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಏನಾಗುತ್ತೆ, ಸಿ ಡಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಓ ಎ ಇಂಟು ಸೈನ್ ಎಕ್ಸ್. ಇಯರ್ ವಿ ಹ್ಯಾವ್ ಟು convert CD as well as AB in terms of OA because middle term we have OA, that's why. Therefore CD is equal to OA into sin x. Call this as 2. And from the right angle triangle what we have here? From triangle OAB. From right angle triangle OAB, here we will consider tan x. Trigonometric ratio tan x. So tan x ಏನಾಗುತ್ತೆ, tan x is equal to opposite divided by adjacent. Opposite ಏನಿದೆ ನಮಗೆ AB, opposite is here AB divided by adjacent is OA. Adjacent is OA. Therefore AB ಏನಾಗಿ ರೆಡ್ಯೂಸ್ ಆಗುತ್ತಪ್ಪ, AB is equal to OA into tan x. So call this as 3. ಅರ್ಥ ಆಯ್ತಾ ಮಕ್ಕಳ? Here what we have the radians, x is different from 0 to pi by 2, in between 0 to pi by 2. And remember here, so we got the expression for CD. CD is equal to OA sin x and AB is equal to OA tan x. ಅರ್ಥ ಆಯ್ತಾ ಮಕ್ಕಳ? So take a pause and note down all the things what I have written here. ಬರ್ಕೊಂಡ್ರೆ ಮಕ್ಕಳ, ನೆಕ್ಸ್ಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ 2 and 3 in 1. Substitute 2 and 3 in 1. So what we get here, substitute 2 and 3 or equation 1 and 2, 3, 2 and 3 in 1. We get, ನೋಡಿ ಫಸ್ಟ್ ಟೈಮ್ ಇರುತ್ತೆ ನಮಗೆ ಸಿ ಡಿ ಇದೆ. ಸೊ ಸಿ ಡಿ ಇಸ್ ರಿಪ್ಲೇಸ್ಡ್ ಬೈ ಓ ಎ ಸೈನ್ ಎಕ್ಸ್. ಓ ಎ ಸೈನ್ ಎಕ್ಸ್ ದಟ್ ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ ಎಕ್ಸ್ ಇಂಟು ಓ ಎ ಲೆಸ್ ದ್ಯಾನ್ ಎ ಬಿ ಇಸ್ ರಿಪ್ಲೇಸ್ಡ್ ಬೈ ಓ ಎ ಇಂಟು tan x. OA into tan x. Just observe here, OA, OA, OA ಇದೆ. In all the three terms containing OA. So divide by OA. Throughout divide by OA. So what we obtain? Divide by OA. Just observe here. This is OA into sin x divided by OA less than x into OA divided by OA less than OA into tan x divided by OA. Here OA and this OA get cancelled, here also these two get cancelled, here also these two get cancelled. So finally we left with first term is sin x less than x less than tan x. So tan x is also can be written as sin x by cos x ಬರಿಬೋದಲ್ವಾ? Remember sin x divided by cos x, the quotient form of tan x, sin x divided by cos x. Just observe here, so here what we define x, the angle, it is from 0 to pi by 2. So 0 to pi by 2 means it is lies in which quadrant? First quadrant. First quadrant means all trigonometric functions are positive, hence sin x is also positive. If I divide by sin x for this inequality, nothing will changes here because sin x is positive. Divide by sin x, it will ಬರ್ಕೊಡ್ರಿ. Sin x is positive in 0 less than x less than pi by 2. So here what we left is here sin x divided by x, sin x less than x divided by sin x less than sin x divided by cos x into sin x. This is the dividing term. We are divided by sin x. Here sin x and sin x get cancelled. here sin x and here sin x get cancelled. Here we will left with 1 less than x divided by sin x less than what? 1 divided by cos x. 1 divided by cos x. Next we have to take the reciprocal for this term. Take reciprocal. Just remember the properties of linear inequality. Whenever both a and b are positive and a is less than b, obviously if you take the reciprocal, in that case ಏನಾಗುತ್ತೆ ಹೇಳಿ, the sign of inequality reversed. Similar here also, if I take the reciprocal for this inequality, sign of inequality reversed. That 1 divided by 1 ಆಗುತ್ತೆ, that becomes greater than sin x divided by x, that is greater than what? 1 by cos x ಇದೆ, that cos x goes here and 1 comes to denominator. This is the thing we obtained here. Okay, then 1 divided by 1 is 1, greater than sin x divided by x, greater than cos x. ಅರ್ಥ ಆಯ್ತಾ ಮಕ್ಕಳು? ಗ್ರೇಟರ್ ದ್ಯಾನ್ cos x. ನೋಡಿ 1 greater than sin x divided by x, greater than cos x ಇದೆ. So this can be written as, first write cos x, this is less than what? Sin x divided by x less than 1. This is the things we obtained here. So ನೋಡಿ sandwich theorem statement prove ಆಯ್ತಲ್ಲ, ಇಲ್ಲಿ cos x less than sin x divided by x less than 1. Now take limit as x tends to 0 throughout this expression, throughout this inequality. So what you obtain? Limit as x tends to 0 of cos x less than limit as x tends to 0 of sin x divided by x less than limit as x tends to 0 of 1 ಇದೆ. 1 is here constant. It does not contain any term of x, hence the limit of the function 1 when x tends to 0 is also 1. So apply the limit as x tends to 0. Replace x is equal to 0 here. We left with here cos 0 less than limit as x tends to 0 of sin x divided by x. This is less than 1. Observe Mari. What is cos 0? Very good. Cos 0 is 1. So what do we left with finally here? 1 is less than limit as x tends to 0 of sin x divided by x is less than 1. It means the limit of the function, limit as x tends to 0 of sin x divided by x is greater than 1 as well as less than 1. So what we conclude here? Obviously the limit as of sin x divided by x when x approaches to 0 is 1. Therefore limit as x approaches to 0 of sin x divided by x is equal to 1. So this is our result. ಅರ್ಥ ಆಯ್ತಾ ಮಕ್ಕಳ? Here the important concept is circle. Circle ಅಲ್ಲಿ ಏನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ? We will consider area of first triangle, area of sector and area of the bigger triangle, the largest triangle. So first one is triangle OAC. Area of triangle OAC is less than area of the sector OAC and it is less than area of the triangle OAB. Next step is simplification. After that one we will take the limit whenever x approaches to 0. This is clear Mukta? Okay. Take your pause and note all the things what I have written here. Illa broken ra. So here we have the very important result. Whenever limit x tends to 0 of sin x divided by x becomes 1. Similarly, nodi sin x, sin of 2x divided by 2x ಇದೆ. In that case also x becomes 0 means we will get 1. We will discuss problems on this topic. So before going to that, we will discuss about very important result for tan x divided by x and 1 minus cos x divided by x. Okay, now first one, Prove that limit as x approaches to 0 of tan x divided by x is equal to what we have here? 1. So we will prove this by using sandwich theorem, what we discussed here. The important result, sin x divided by x whenever x approaches to 0 is 1. Proof for first one today. Consider L is equal to the given limit as L is equal to limit as x tends to 0 of tan x divided by x is L is equal to limit as x tends to 0 of, just remember the formula for tan x in quotient form. So we have the quotient form is sin x divided by x. So this can be written as 1 by x into sin x divided by cos x. Quotient form of tan x is sin x divided by cos x. Okay. So I will rearrange this term as limit as x tends to 0 of sin x divided by x. Sin x divided by x. First combine these two terms and then we will have with 1 by cos x. 1 divided by cos x. Therefore L is equal to limit as x tends to 0 of, this can be written as, it is just like a f of x into g of x, product of two functions. So either we can directly apply the limits or split the limit. This can be written as sin x divided by x into limit as x approaches to 0 of 1 over cos x. So this we have a standard result for this one. Limit as x approaches to 0 of sin x divided by x is 1. Therefore L is equal to, this is 1 into 1 divided by, apply the limit here, cos of 0. L is equal to 1 into 1 over 1. L is equal to 1 into 1, that is nothing but L is equal to 1. Therefore limit as x approaches to 0 of tan x divided by x is equal to 1. This is also standard result. Just remember the result, limit as x tends to 0 of sin x divided by x is equal to 1, as well as limit as x approaches to 0 of tan x divided by x, that is also 1. So these two are the very important and they are the standard result. Take a note. Nowadays students, we are moving to the next important result. Prove that whenever limit x tends to 0 of 1 minus cos x divided by x is equal to what we have here? 0. First two are 1 and third one is 0. We will prove this one. Similarly for this one is also, consider this as a limit L. Let L is equal to limit as x tends to 0 of what we have here? 1 minus cos x. This is second one. This is 1 minus cos x divided by x. This becomes here L is equal to limit as x tends to 0 of, just remember the formula for cos of 2x. For cos of 2x we have four formulas, right? One is cos square x minus sin square x, 2 cos square x minus 1, 1 minus 2 sin square x, and another one 1 minus tan square x divided by 1 plus tan square x. Okay, so using that formula we can extract another thing. So whenever we have 1 plus cos x, 1 plus first cos of 2x, everything 1 plus cos of 2x can be written as really 2 cos square x. Similarly 1 minus cos of 2x ಏನಾಗುತ್ತೆ 2 sin square x ಆಗುತ್ತೆ. So here we have two angle, multiple of angle. Suppose the same formula now will reduce for cos x. In that case that becomes 1 minus cos x is equal to, 1 plus cos x is equal to 2 cos square x by 2 ಆಗುತ್ತೆ. 2 cos square x divided by 2. Similarly for next one 1 minus cos x ಏನಾಗುತ್ತಪ್ಪ 2 sin square x by 2 ಆಗುತ್ತೆ. It means ಇಲ್ಲಿ 2x ಇದೆ. So 2x ಅನ್ನು x ಗೆ ರೆಡ್ಯೂಸ್ ಮಾಡಬೇಕಾದ್ರೆ we will divide by 2, right? Whenever here divide by 2, at the same time here also divide by 2. We left with x divided by 2. Okay. Okay, so what was the expression for 1 minus cos of 2x is 2 sin square x divided by 2, this one. 1 minus cos of 2x is 2 sin square x. Similarly, 1 minus cos x is 2 sin square x divided by 2. So therefore this becomes 2 sin square x divided by 2 divided by x. L is equal to limit as x approaches to 0 of, so this 2 will take for denominator and sin square x by 2 can be split as 2 terms. First one ಏನಾಗುತ್ತೆ ನೋಡಿ, sin of x by 2 ಆಗುತ್ತೆ, this 2 comes to denominator, that becomes here x divided by 2, right, into sin of x by 2. Limit as x approaches to 0 of sin x by 2 divided by x by 2 into, for second term, limit as x approaches to 0 of sin x by 2. Just observe here, whenever x approaches to 0, at the same time if I multiply for this term for 2, 2x is approaches to 0, right? Here multiply 2 means here also 2 into 0, that is also becomes 0. Similarly, x divided by 2, that is also approaches to 0. This is clear here. Nodi, x tends to 0 is nothing but x by 2 tends to 0. Illi nodi, sin of x by 2 ide. If the denominator have the same term, limit extend to 0 idaga, this value becomes 1. Remember, this value becomes 1. Suppose this is sin y divided by y, when y approaches to 0, that is also 1. Sin of 2z divided by 2z, when z approaches to 0, that is also 1. Or ಇಲ್ಲಿ ನೋಡಿ, sin x divided by 3 ಇದೆ, ಇಲ್ಲಿ also x by 3 ಇರುತ್ತೆ, whenever x approaches to 0, that is also 1. So these two must be same. The internal function of the sin x and the denominators are same. When they are same, here limit approaches to 0 means the value becomes 1. So therefore this value ನೋಡಿ, x tends to 0 na x by 2 tends to 0 ಅಂತ ಅನ್ನೋದು ಬರೀಬಹುದು. Okay, this value becomes L is equal to, this is here 1 into, apply the limit for this one, sin of 0 divided by 2, this is L is equal to 1 into sin 0. Therefore L is equal to what, 1 into sin 0 is 0, therefore L is equal to 0. This is our limit. ಅರ್ಥ ಆಯ್ತಾ ಮಕ್ಕಳ? So concept is very simple. ನೋಡಿ, whenever limit x tends to 0 of sin x divided by x, that is 1. ನೋಡಿ, x ಇರೋ ಟರ್ಮ್ಸ್ ಅಲ್ಲಿ we can substitute 2x, 3x, 4x. Here x tends to 0 means here 2x tends to 0, 3x tends to 0, 4x tends to 0, or x by 2 tends to 0, x by 5 tends to 0, pi into x tends to 0. The internal function of sin as well as the denominators are same, then the limit becomes 1. Then the limit becomes 1. ಅರ್ಥ ಆಯ್ತಾ ಮಕ್ಕಳ? This is very important. So we have discussed about 3 important result in this class. First one, limit as x approaches to 0 of sin x divided by x is equal to 1. Similarly for limit as x approaches to 0 of tan x divided by x is equal to 1. And the last one, limit as x approaches to 0 of 1 minus cos x divided by x is equal to 0. Take a pause and note all the things what I have written here. ಎಲ್ಲ ಬರ್ಕೊಂಡ್ರೆ ಮಕ್ಕಳು, next class we are going to discuss about problems on using these result or evaluation of the limits when they given trigonometric functions. We discuss in next class. Thank you all.